Hello everyone, welcome back to week 2 of the Blockocast competition. This is DAKSHAN of first year CSC department, and today we are going to see about consensus mechanism beyond proof of work and proof of stake. What is consensus mechanism? A consensus mechanism is a protocol that brings all nodes of a distributed blockchain network into agreement on a single dataset. They act as the verification standards through which each blockchain transaction gets approved. So it is basically a self-regulatory stack of software protocols written into a blockchain's code that synchronizes a network into agreement about the state of a digital ledger. This is done by upkeeping a single dataset, the mutually agreed upon version of a blockchain's transaction history, rather than employing each node or in-network computer to individually maintain their own copy of the database in its entirety. Although there are a variety of consensus mechanisms to consider when programming a network standard for verification, each approach is wired to discredit cheaters in their attempts to contradict the record. How does consensus mechanism work? Nodes input data from a pending transaction, then report back with an approval or disapproval status once the request is cross-checked with its record. For example, if a user is trying to process a transaction using previously spent coins that have already been accounted for, this request would usually be denied against an immutable ledger, confirmed by majority disapproval. Users that fail to adhere to consensus are often banned from a network. In the event a node wanted to challenge the record, they would have to request a network-wide recall. If more than two-thirds of their peer nodes approve, then the transaction is confirmed, distributed, and permanently written into the blockchain. Consensus simply means an agreement between a group of people, and in the world of blockchain, it is an important concept. Consider a mechanism role in decentralized finance. The core centralized framework built into most institutions, such as banks, rely on a decision making authority to approve or reject transactions between two parties. Cryptocurrencies, however, don't have this option since they are typically operating on decentralized platforms. Instead, they are consensus mechanisms, which validate live copies of a transaction history network wide. This keeps everyone in the blockchain accountable to whether a transaction should be approved or not. Common example of consensus mechanism in blockchain include proof of work, in which crypto miners are handsomely rewarded newly generated tokens in exchange for authenticating transactions by way of solving arbitrary computational puzzles, and proof of stake, where users put up a certain amount of tokens for a chance to earn rewards through transaction verification in a raffle. Staking more tokens gets the owner more lottery tickets. We'll see more on proof of work and proof of stakes in the upcoming slides. One of the most helpful examples of consensus mechanism is action. In action is the way that humans agree on the rules of a game. Pointing to a game of Monopoly as an example, there are a lot of different ways to win the game. You could buy all the properties, you could end up with a lot of money in your bank account, or you could bankrupt all your opponents and win that way. But no matter what strategy you use to win, everyone playing has agreed that it is a fair way to end the game. Just like your dad can't unilaterally declare eminent domain in Monopoly, nodes in blockchain can't reassign ownership of tokens without getting the majority of other participants in the network to agree. Types of consensus mechanism. Blockchain platforms have written and rewritten the rules of consensus in their search for the Holy Grail, a perfect equilibrium of decentralization, scalability, and security. Because of this, a small library of methodologies have been developed for Web3 applications. Here are the five most common consensus practices: proof of work, proof of stake, delegated proof of stake, proof of authority, proof of history. Now let us see about proof of work. Proof of work is a consensus mechanism commonly used in blockchain network to secure and validate transactions. It was first introduced as a solution to the Byzantine generals problem, which addresses the challenges of achieving consensus in a decentralized network where some nodes may be malicious. The genesis of all consensus mechanism proof of work depends on an army of miners or validators to verify transactions through solving arbitrary mathematical problems we raise for a block price. Essentially, the energy intensive process hires a network of specialized computers to solve for x, with x being a 64-digit hexadecimal number known as a hash, which is encoded by cryptography. Crypto mining, the block generative process described above, can reap thousands in rewards in the form of new crypto tokens. It's a popular use case for proof of work systems. The pros of proof of work systems: arguably the most decentralized and secure of all verification mechanisms, lauded as extremely reliable. In the case of Bitcoin, a generous bounty for block validation, currently valued at around $16,800, has resulted in high engagement on the platform. Cons of the proof of work: slow transaction rates, expensive gas fees, expensive operational fees, and eco-hazardous energy usage summarize the inefficiency associated with proof of work system. Bitcoin's average block time, the time it takes to process a transaction, is 10 minutes, and the process requires a staggering amount of electricity. Some examples of proof of work are Bitcoin, Dogecoin, and Litecoin. Proof of stake. Proof of stake is an alternative consensus mechanism to proof of work commonly used in blockchain networks. Unlike proof of work, where participants compete to solve mathematical puzzles, proof of stake selects validators to create new blocks and validate transactions based on the amount of cryptocurrency they hold and are willing to stake as collateral. In a proof of stake model, users pledge a designated number of tokens in a process known as staking to receive validator privileges. When the user's coins are staked, this means that they are locked away for the time being. Staked coins passively earn rewards and contribute to the network until the user unfreezes them, most often for the purpose of a trade. Validating opportunities are rewarded at random, in a sort of lottery pool to eligible validators. The more tokens staked, the likelier a user's chance are to win the raffle. In addition to processing trades and adding blocks to the blockchain, validators stand in as active community members responsible for storing data. If any user breaks consensus, their stake is forfeited. Pros of proof of stake: the optimal method of consensus in Web3 for scalability. It's both energy efficient and inexpensive in respect to both gas fees and equipment. Cons: not as decentralized or secure as proof of work. Power is delegated by wallet size. Examples: Ethereum, Cardano, Tesos, Algorand. Now let us see about delegated proof of stake. In delegated proof of stake, a certain number of nodes are elected by the network stakeholders to act as block producers. These nodes are responsible for validating transactions and creating new blocks. Delegated proof of stake aims to combine the advantages of decentralization with increased transaction throughput, as only a limited number of nodes are involved in the consensus process. Imagine proof of stake, but with an electoral process. In this approach to determining consensus, network participants cast votes via staking pools for their favorite delegate, those who are presumed to be best to protect the network based on reputation. As a result, validating privileges are reserved and awarded at random only to a team of top tier candidates at any point in time. A validator can be surpassed by someone deemed more trustworthy. Pros of TPOS: this system is efficient and democratic. It improves from the original proof of stake method by being more financially inclusive to users and provides incentive for validators to remain accountable in keeping the network alive. Cons: while there is an obvious trade off of decentralization, a delegated proof of stake protocol may be considered too high maintenance for some users as it requires a healthy level of engagement. Appointing network control to a few over many also increases its vulnerability to malicious actors, such as in a 51% attack. Example: EOS, Lisk, Arc, Tron, BitShare, Steam. Proof of authority. In proof of authority, a fixed set of authorities are pre-approved to validate transactions and create new blocks. It is commonly used in private or consortium blockchains where trust and identity are already established. Favored by private or permission blockchains, a proof of authority consensus mechanism selects validator based on reputation rather than a user's digital assets. In this system, a group of validators are pre-approved in a vetting process that often includes a background check. Pros: this method is highly scalable and requires virtually no computing power. Con: any structure designed to concentrate power compromises decentralization. Additionally, a validator's pseudo-anonymity is forfeited, as public identifiability is part of the deal. Example Zodex, JP Morgan, JPM Coin, VChain, VET, and Ethereum Kovan testnet. Proof of history is a novel technique used in blockchain systems to ensure historical data is accurate and has not been tampered with. This is achieved by using a hash function to create a unique fingerprint of a set of data, for example, past transaction. This is then included in a block on the blockchain and can be verified by the nodes currently protecting the blockchain. These nodes can compare the fingerprint with the current state of blockchain data to confirm its validity and accuracy. Proof of history integrates the element of time into a blockchain's protocol. During the verification process, timestamps are embedded into the hash of each generated block, chronicling a network's transaction history in a singular, unbroken chain. It's important to note that this verification method is only viable as a supplement to another protocol. The hybrid consensus algorithm is often seen working in tandem with a proof of work or proof of stake system. Pros, it's fast and secure without negating a platform's existing state of decentralization. Proof of history is also associated with low transaction cost or gas fees. The most well-known platform that uses proof of stake, Solana, is widely regarded as the fastest blockchain in existence, boasting 400 millisecond block times. Cons. A major disadvantage to high transaction speed is the amount of data that accumulates. The hardware fit to run such advanced software disqualifies the average user from being able to serve the network as a validator. Example Solana. Thank you. Thank you guys for listening to the end. We'll see you people next week with another interesting topic. Till then, goodbye.